All right, let's first, before we talk about complex roots, let's just talk about Euler's formula, which is something that you may have seen in Calc 2. I know I teach it in Calc 2, but I know not all teachers teach it in Calc 2. And this is talking about basically what happens when you have a complex argument in your exponent. Okay. And it actually has this nice representation of cosine theta plus I sine theta. Okay, and you can get that from your Taylor series. Okay, so e to the x, you may remember the Taylor series for e to the x. If not, then you should. And by should, I mean it's never too late to start remembering it. Okay, you should also remember the one for cosine of theta, or x. Cosine of x, remember, is the even ones. Okay, so it starts at 1. Minus, oh, let me rewrite that. And it's all the even ones in alternating form, right? Okay. And then sine of theta, or sine of x, is all the odd ones. All right, sine of x is all the odd ones. Starting with x, again in alternating form. Okay, so let's start by let's do e to the I theta. E to the I theta is going to be 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial. Do plus I theta to the 5th over 5 factorial. Oh, sorry. To the 4th, getting ahead of myself, literally. Plus, let's do one more. I theta to the 5th over 5 factorial. That's e to the I theta. Now, one thing to remember about I, which I know we don't teach it here, and I'm sorry, but that's just how it is. I, first one is just I. I squared is -1. I cubed is actually, if you think about it, I squared times I is going to be -I. And then I to the 4th equals 1 again. Okay, so then I to the 5th equals I. I to the 6th equals -1. I to the 7th equals -I again. And I to the 8th equals 1. And we could keep going like this forever, okay? So we're going to play this game with this series. So whenever it's an even power, it's going to be, we're going to split it up into the ones that have even powers and the ones that have odd powers. Okay, so e to the I theta is going to be 1. This one's going to be a negative, but then it's going to be theta squared over 2 factorial. This one's going to be a positive theta to the 4th over 4 factorial. The next one would be to the 6th, and it would be to the negative. Let me move this down a little bit. Okay, and it's going to keep on going like that. Let's take the odd ones. We're going to have an I that we're going to pull out because all the odd powers are going to have an I or a negative I. Okay, first one's going to be theta. Oops. Now, to the third, that has a negative sign. So it's going to be minus theta to the 3rd over 3 factorial. To the 5th, it's going to be a positive sign. Theta to the 5th over 5 factorial. Minus theta to the 7th over 7 factorial. But wait, look. This series is right here. And this series is right here. Okay, so that's where you get e to the I theta equals cosine theta plus I sine theta. And that is our famous Euler formula. Okay, and it's one of the most useful formulas you'll ever see. Okay, all right, we'll be back with solving differential equations with complex roots next.